So I think it's the 13th, right? Okay, so we have a square. Doesn't really look like a square. So anyway, so this is x, 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 and x, right? So we're given a sheet of metal that is a square. Good. Then I remove corners that are 4 by 4. I remove this corner, and all of them, 4 by 4. Gabe, you need some paper and a pencil to write on? It's a math class, I wish. Here it is. Okay. So let me illustrate with this. Assuming that this is a square, assuming it's not a square. So I'm going to remove this piece. I'm going to remove this piece, and I'm assuming that all are equal in size and 4 by 4. And then I fold this side, and then this side, and then this side, and then this side. And bear with me and say that this is a box. Nobody believes it, but let's say it's a box, right? What will be the height of the box? 4. Do you all see it, right? That's what I removed. I removed 4, correct. What will be the length or the width? They're all the same. Everything is a square. So what would be this? Knowing that I started with x, what do I have now as the length of the box? One more time. X minus 8. X minus 8. Very good. So then the box looks like this, and 4, 4, 4, and of course x minus 8, and so on and so forth all around. Do we understand this step? Everyone? Yes? Okay. We are told that the volume is 196. Is it inches? Yes. Okay. In that case, it's cubic inches. So if x is the unknown, and this is 4 inches, then we are given the volume as being 196 cubic inches. So we are asked in this problem, what is x? That's what we want. We want to find x. We know that we created a box, and the volume of this box now is 196 cubic inches. So x minus 8, x minus 8, x minus 8, x minus 8, 4. What is the volume of a box? What is the formula for the volume of the box? This is a box. This room is a box. It's not square, but it's a box, right? So how do I determine the volume of air, if you want? The capacity of this room. How do I determine the area of the floor? Length times width. What will be the volume then? Length times width
times height.
Times height, indeed. So the volume of a box is length times width times height. So the volume is 196. What do you think I would write it? Set it equal to. What do I get on the other side? What is the length? What is the width?
Four.
Of course. Multiplied by the height. What is the height?
4.
Very good. Excellent. So length times width times height equals 196. What type of equation is it?
Equation.
Remember the two concepts. What type of polynomial is one thing. What type of equation is something else. So what type of equation is it? Quadratic equation. Good. Which of the 4 methods I will think of applying?
Taking square roots.
Of course, but it's not cleaned up yet.
No.
As I said, you could teach the class. Can I sit down? Okay, so what will I have to do first? Exactly, clean it up. So divide both sides by 4. So the left-hand side is x minus 8 squared, and the right-hand side, 196 divided by 4. So 40, is it 49? Correct me if I'm wrong.
No.
4 times 4 is 16, and then 36. Am I correct? Okay. So now it's completely cleaned up. We know what method we want to apply because this is already set up for that method. And let's do it. Once again. Very good. But again, the equation is quadratic. How many solutions will I get? Very good. So don't forget what we need to write. So the left-hand side is? Very good. The right-hand side is? Very good. So from here we have x equals 8 plus or minus 7, and we have to separate it. So one solution, and do not forget the measurement unit. What was the measurement unit for the length and width of this box?
X minus 8 squared.
So what was the measurement unit? Yes? Inches. Very good. So 8 plus 7, indeed, 15. And the other one, indeed, 1. Good. So now we have to make a decision. The decision that we have to make is 15 the only one? Is 1 the only one? Or both of them work? Right? So let's plug in 15. 15 minus 8. 15 minus 8 squared. Right? What will be 15 minus 8? 7 squared. 7 squared is 49 times 4 is 196. Now I'm going to plug in 1. X minus 8.
That's -7.
Can I have a length of -7 inches? No. So then I know the only solution is 15. Very good question. Thank you for bringing that up to me. I'm sorry? Is it okay?
Yes.
Every step? Yes. X.
It wants the length of the open box.
So what, I don't know, we have to read what the question is. What does it say? The length and the width. So you only put 15? But it's length and width. 15 comma 15. Or by 15. I'm not sure how they want it. So they want 2 different numbers. It happens that they are the same, but they want 2 different numbers. They want the length and the width. So I would put 15 comma 15. So your answer is not correct. Correct answer is 7. So we had 196. Did I copy something wrong? Okay, that's okay. So let's see what happened. So we had
There's an x.
x minus 8.
The length and the left of x minus 8. So when
So,
width just end up being 7. So it'd be 15 minus 8.
oh, the length of the box they wanted. They don't want the length. I'm sorry. They don't want the length of the box. They want they don't want the length of the sheet of metal. They want the length of the box.
Oh, okay.
That's why. Yeah, we have to be very careful by what they are asking. So it's 7 by 7. Or just 7. I don't know if they want 2 numbers or, yeah. So everything is fine. It's just that they are asking for this dimension, which is 7, not for the whole x. Is that better? Is that clear? Okay, very good. Good. Other questions, please? Is there anything else that you worked on? If not, I'd like to go back to the, yes, Priscilla?
It was number 3 for 1.5. It was 5x squared minus 27x minus 18. That's it.
So we're asked to factor?
Yeah.
Okay, very good. So in this situation, we are going through the strategy step by step. What is it? Now I'm asking what type of polynomial it is, not what type of equation, because this is not an equation. So what type of polynomial is it? Excellent. Descending order?
Yeah.
Negative leading coefficient? Greatest common factor? 5, 27, and 18, nothing in common. Is this a special product?
No.
No, because this is not a perfect square and this is negative and not a perfect square. Is 1 the leading coefficient?
Nope.
No. So my only chance is the last step, the last possibility, the long method, in which I need to find two numbers whose product is and whose sum is.
No.
90. The top is 90.
Okay, so you multiply 5 by 18.
Yeah.
Okay,
Is that
so what do you get?
90?
No, indeed. This is extremely important. If we miss the sign, then we will have difficulties in finding the numbers. So all numbers are taken with a sign in front. I can't separate a number from its sign. So 5 times this negative 18 is negative 90, and the sum is?
Negative 27.
Very good. Now, I do start with the product, always. Why I start with the product? Because I see the product is negative, and that tells me something very important, that we are looking for A and A.
Negative and positive.
That's crucial. That's the very first step. Since the product is negative, I'm looking for a positive and a negative. Good. So now let's look at 90. 90 indeed is a big number if you want. So for now it's 9 times 10, and then 3 times 3, and 2 times 5. So I have in the correct order, in ascending order, I will do this. Okay? Yes.
Are you asking like the numbers?
Yes. What are the numbers? Yes.
That's what I
So negative 30 and 3. So negative 30 and 3. The product must be negative 90. The sum must be negative 27. But at this point is the long method. You have to replace this. You cannot go ahead directly and write the factored form.
Yeah.
Awesome. We did that a few problems together last time, right?
yeah, something like that.
Good. Yes. So now, and next step, I have 5x squared plus 3x minus 30x minus 18. It doesn't matter. The order is not important. I wrote 3 negative 30. You can write negative 33. It doesn't matter. As long as now you do not look at the other two. This is also crucial to get into the habit of not looking, because if you look, you may write something else. You get stuck. You'll never factor. So what do you factor out from the, yes?
It is easier if you switch the door, because then you can.
It doesn't matter. The answer will be the same.
Say it's easier. 5 and 3 can be.
Doesn't matter. Let's do it this way. You do it the way you like. It doesn't matter. So what did you factor out from the first two? X. What is left in parentheses?
That's 30.
Good. What do I have to get from the other two before I look?
You put the 5 next to it.
I have no choice. If it's not there, I know it's there. How do I know it's there? Because I found the two numbers. Once I found the 3 and negative 30, and the product is negative 90 and the sum is negative 27, I know this is factorable. I know that this 5x plus 3 must be there. And only now I look. What do I get? I need two things. This is very important. I need a sign and I need a factor. If you write them like this, you will never factor correctly. You have to leave space between this and this. If you write like this, you're not going to put anything. You have to have a sign and you have to have a factor. So what is the sign and what is the factor that I need to put in?
Yeah, negative 6.
Good. So now we have 5x plus 3 and x minus 6. Any questions? Is this better? Priscilla? Is this
Yeah,
better?
This makes sense.
Good.
I don't know why, like, the questions that we had worked on together that were kind of like the same, like,
Yeah.
concept. I'm not sure if I did them differently with a different question, so it's kind of follow the same process. But
Yeah, you should redo those problems several times before
I did
proceeding.
them several times.
Yeah,
I
well,
just got stuck on that.
sometimes it takes time. It's okay. No worries. Just stay with it. Anything else? So I'd like to go back to the absolute value equations. Just to refresh your memory, you may remember this from a previous class, that there are basically 4 different situations here. We are in this class, however, we are not going to look at all of them. I just wanted to give you the heads up. So there are 4 possibilities for answers. 1 solution, 2 solutions, no solutions, and infinitely many. We're not going to look, I did not see any example like this. In the previous class, I taught all 4, the prerequisite for this class, but I didn't see any infinitely many, or maybe my colleagues, when they created the my math lab, they didn't put in. If you come across any equation with 2 absolute values, I would like you to point that out to me, and because I don't see any in the book. So I'm just going to omit this one. When will an absolute value equation have 1 solution? Here's the option, or the example. In this case, this equation has only 1 solution, because you cannot say that x plus minus 3 is plus or minus 0. So there is only one option with x minus 3 equals 0, which means x equals 3. So that's the 1 solution. We saw last time several examples with 2 solutions, but we did not see last time this one or the no solution. So here's an example with no solution. 2x minus 3 equals negative 4. This equation is an absolute value equation, but it has no solutions. Can anyone say why this equation, the last one, has no solutions?
Because 2x minus 3 is a negative 4.
Right, because this is always a distance. This is always a positive number on that side, and a positive number could never equal a negative number. There's no such thing. Good. Any questions? Any questions? So we are back to 1.7. Hopefully we'll finish this today and start chapter 2. So back to 1.7, we only looked at linear inequality, I meant to write. Linear inequalities. So we looked at a few examples with linear inequalities and writing the solution in interval notation. Now, what is the remainder of this section is absolute value inequalities. Absolute value inequalities. There are 2 types. First, I would like to create very simple examples and talk about them, and then we're going to look at more sophisticated problems. So here's an example. Of each type. So 2 types. Can anyone tell us what is different here and why I call them 2 different types, or I claim they are 2 different inequalities? Yes, please.
One is equal to, one is greater than. One is equal to 5, greater than or equal to 5, one is less than 5.
So this one is less than or equal to, and this one is greater than or equal to. They must be different. They must be different, correct? Would you agree?
Yeah.
The one that is less than cannot be the same with the one with greater than. Perfect. So now, what does the first one say? And if you want me to write it, put it in writing, I will. The first one says this. It's going to be long, but easy, I would say. Find the values of x, find x, such that the distance, this is the distance from x to 0, right? So find values of x whose distance from 0 is 5 units or less. Find x values whose distance from 0 is 5 units or less. Where will I find those numbers? Yes, where? Exactly, yes. Of course. On the number line or real line, it's called, yes, where will I find them? So this is negative 5 and this is positive 5. Where will I find them again? Where? but there are different possibilities. So this is a possibility, this is a possibility, this is a possibility, this is a possibility. Where will I find them? Awesome. In between what? Of course. Makes sense. So this inequality has these solutions. Awesome. This is the, so all these x values represent the solutions to this. Awesome. That's all I need to know. Now let's look at the other one and let's read the other one. Can anyone read the other one for us? Find x, whose distance from 0 is
It's 5 from 0.
to the left of,
0. 0.
to the left of,
Okay.
you cannot include what is already taken. What is already taken is taken. So that cannot be, again, part of something else, right? If it's less than 5, it cannot be also greater than 5. So what is taken, you cannot touch. So then, I'm looking for what? Numbers that are further away. Further away. So, can anyone give us a solution? X must be to the left of
Negative 5.
or to the,
Right of 5.
excellent. Makes sense. So it's definitely this piece and this piece. These two pieces solve this inequality. That's all I need to know. This is the concept. There is nothing else to it. But yes, the inequalities will not look as simple as these two. But once we simplify them to this level, we will be able to write the solutions. So now how do I write the solutions for these two in interval notation? The solution for this, very simple. Negative 5, 5. Done. The solution for this, however, has to include negative infinity to negative 5 with a bracket and the union symbol, 5 to infinity. This is or the union symbol. I'm sorry? Both intervals. Correct, yes, yes. Both of them. Good, so that's all we need to know. Now we are ready for, let's say 68 on page 203. 3 times x minus 1 over 4 in absolute value, less than 6. What is, well, I have to identify what type it is. What type is it? Because there are two types. The one with less than or the one with greater than.
This is a less than.
Less than, but careful. If I have the inequality set up like this, which means the number on the left-hand side and the absolute value on the right, it may be different. So be very careful. Always rearrange the inequality with the absolute value on the left. You can always reverse them, right? If you need to. Good. So it is the less one, less than. If it is the less one, it means less than. It means that it's easier than the other one, right? So what do I have to write? Imagine like I'm telling you the distance from 0 has to be less than 6. So I'm we're asked to determine these numbers whose distance from 0 is less than 6. Where will I find these numbers?
Between 6 and 0.
Between?
6 and 0. Less than
Very good. 6 and negative 6.
Absolutely.
Very good. Between negative 6 and 6. So one remark. Remember, you cannot distribute, you cannot multiply, you cannot touch this. So please do not try to distribute or subtract or multiply both sides by 4. You cannot do that. You cannot touch anything that is in the absolute value. Absolute value bars are not grouping symbols. You cannot put anything in, you cannot take anything out. You cannot multiply, you cannot simplify. Untouchable. If I don't know how to convert this inequality into this one, I will not be able to solve. Or at least not solve correctly. Good. Now this I can solve. What do I need to do first?
Okay. I saw that we could about the absolute value, like if it's a positive number on the side,
We don't have numbers, we have variables. We can't do that.
so it was number correct, right?
I don't have numbers, I have expressions. I can't touch anything that has x in it, in the absolute value. If the absolute value of 5, then I'll write 5. But that's not what I have. I can't touch anything in this case. Good. So what is the first step next? Very good question. Excellent. Well done. How?
Multiplied by 4.
Very good. Awesome. But everything, not just the inside, all sides. So this is negative 24, less than 3 times x minus 1, and less than 24. Awesome. That's the starting point. I need to get rid of the denominator. Perfect. Then, next step. I would, but it's not a mistake, but I'd like to do something else. It's perfect answer. All 3 sides divided by 3. Excellent. Well done. Great. So this is negative 8 less than x minus 1 less than 8. You would have gotten the same answer by distributing. I just wanted to show a different way. Absolutely. Final step and we're done. Exactly. Awesome. So then we have negative 7 less than x less than 9. In interval notation, yes,
I just have a question about
please.
how you're
Yes,
writing it.
yes.
Do you want us to write it like when we show our work? Because when I did it, like when I was doing the homework, I just separated into 2 separate problems. Is that okay to do as well?
Never.
Just write it out like that. the whole
You
thing?
will probably get the same answer, but you may forget to intersect.
Okay.
You have to intersect the solutions. But I would love to see this in the book. Have you ever seen that method in the book, separating it for this particular inequality?
I looked at the book for it. I think I just did
Because if you had seen that, if you had seen that, they are wrong,
Okay.
and I would like to let them know. Okay, there's no such thing. I don't think that they would do something like that. So this is an inequality. They cleaned it up completely. They got 3x plus 5 less than or equal to 10, and they wrote this. They did not separate the inequalities. So please do not separate the inequalities for this one, for the easier one. Please don't do that. You will forget to intersect. And I haven't even shown you how to intersect intervals yet. Okay, so it's up to you. I will accept it if you're on the right track, but it's not a good idea for this particular one. So then I will write x in the interval negative 7, 9 with parentheses, not brackets, because we do not have the equal symbol. The reason why I put x in this interval is because if I just write the interval, you may say, oh, x is negative 7 and y is 9. It's a point. No, it's not a point. It's an interval for x only. That's why I write x is the variable that we are looking for, and it's in the interval between negative 7 and 9.
I didn't see it.
in,
Oh, it's not.
x
Oh.
in. X is found in the interval negative 7 to 9. Good, moving on. Any questions about this?
I have,
Yes, please.
so negative 7 is less than x, less than 9 is not an acceptable answer. Like you have to do the x.
This?
Yeah.
No, I will always ask you for the interval notation.
Okay.
Yes, yes. However, what my math lab may ask you, they may ask you to write the set builder notation. Be careful. If they ask you to write the set, thank you for reminding me, builder notation, if they ask you for that, then you will have to write, and they will probably show this already. I don't like it. I don't care for it at all. It doesn't mean anything. And I'll explain. So what is this? Nothing. You're just copying what the solution is in here. How do we read this? This is a set of values of x. having the property such that, or having the property, this bar, having the property, or such that, or such as, x is between -7 and 9. I don't care for this notation, but my math lab may ask you to put it in. I don't know. So you know what it is. I will not ask you to do that. Okay, let's look at another example. Let's say 78. Any questions for me before we continue? On the same page, 203. So let's say 3 minus 3/4 x in absolute value greater than 9. Okay, can anyone tell us what type it is? There are only two types. Is it the one with the absolute value being less than a number, or is it the one with the absolute value greater than a number? Awesome. So now, remember, this is the more difficult of the two. Why? Because in this case, I have no choice but to separate them. There is no other way. Please do not ever write something like this. This is unacceptable. Please don't ever write something like this. This is unacceptable. So please remember that. So the inequalities can be, if they are compound inequalities, can be this or this. This or this. This, unacceptable. This, unacceptable. So please remember that. Okay, so then what are the two options here?
Is it the same, like -9 and
3 minus 3/4 x. We have to go back to what we just did. Based on what we just wrote here. On this. So what do we write? And the other option, 3 minus 3/4 x. So remember, there are only two options. This option, which is not the case. This option, which is not the case. And the second option, which is this. So what will you tell me to write? 3 minus 3/4 x is that way first.
So then is it negative infinity?
Oh, I haven't solved anything yet. I'm only converting.
Oh, okay.
Sorry, my apologies. I should have mentioned that. Right now, I'm not solving. I'm converting this that is untouchable into the two options that it represents. I'm not. So first of all, I cannot write greater than or less than, right? It's either greater than something or less than something. Say it again. We're not solving yet. We are converting. We haven't written any inequalities yet. We have to write the two inequalities first, right? We don't have those yet. We haven't presented the inequalities that we have to solve yet. So one more time, this is not this, but it's this.
So when you say converting,
I have to convert the inequality with absolute value into two inequalities. So I converted an inequality with absolute value into a compound inequality because I cannot solve this. Here, I have this inequality that has to be changed into two inequalities, but I haven't finished inequalities yet. What do I write? What do you think?
greater than 9.
Say it again.
Greater than 9
Greater than 9. Very good.
and less than 9.
Then I include the middle. I cannot include the middle. The middle is taken already. But then,
is less than negative?
correct. So that's what I'm showing you. To the left of -9, which means less than -9, or to the right of 9, which means greater than 9. Are you with me?
Okay. So
Yes.
every time it has inequality that's greater than the absolute value, this is what we gotta be trying to.
If the absolute value is on one side, on the left-hand side,
Okay, if it's one value,
if it's, I have to have this. So the second inequality, which is this, is here. to the right of 9 or to the left of negative 9. You cannot include anything between negative 9 and 9. Is that better?
And that's for the absolute value is greater than.
For greater than. Yes. Very good. Yes. So now I will subtract 3 from both sides. So negative 3/4 is less than negative 12. And then what do I want to get rid of as the final step in solving for x? What do I need to, exactly. So how do I get rid of this? What do I need to multiply both sides by? Oh, I'm sorry. What do I need to multiply both sides by to get rid of negative 3/4?
Negative.
Negative over the multiplicative inverse. I have to multiply by negative 4/3, right?
Oh, yeah.
To get 1. If I have negative 3/4, I need to multiply by negative 4/3 to get x. The multiplicative inverse, right? If I have negative 3/4, I multiply by 4/3 to get 1. And that's what I want, 1x. But then what do I get here? When I multiply two negative numbers, what do I get? Good. So let's simplify then. 3 by 3 and 12 by 3. What do I get here? Positive what?
16.
Very good. But now I have to think deep. I multiply both sides of an inequality by a negative number. What do I need to do? Awesome. So from less than to greater than. And this is the first inequality.
What did you do when you subtracted 3 from William?
I'm sorry? Say it again.
I thought you lost me when you subtracted 3.
3 divided by 3 is multiplied.
No. First thing you did was subtract 3, wasn't it?
Yes. So I move 3 to the other side. Negative 9 minus 3, negative 12. Exactly the same thing we do in equations. I move 3, which was positive, to the other side, which is negative. Negative 9 minus 3, same process. Is that okay, everyone? Yes? Okay, so then the next one, same step, negative 3/4 x, but this time greater than 6, because I subtract 3. And the same process, I need to get rid of, which one? Negative 3/4, very good. I will multiply both sides by, very good, awesome. Thank you, well done. The left-hand side is obviously x, but now I have to figure out the right-hand side and the sign first. Let's do the sign first. What is the sign of 6 times negative 4/3? Awesome. And I'll simplify. 3 divided by 3, 6 divided by 3. What do I have on the right-hand side? Awesome. I have to think again, because I multiply both sides by a negative number. What do I have to do? Very good. It was greater than, and now it's less than.
You said you multiply by a negative.
Every time we multiply both sides of an inequality by a negative number, we have to switch the symbol. I can give an example. 2 less than 10, if I multiply by negative 1, negative 2 is no longer less than negative 10. That's why we have to switch the symbol of the inequality when we multiply by a negative number. So can anyone give us the solution with the union in between? Here, I don't really have to write x in the interval, but you can. So we have the two options, and we have to write the union in between. Can anyone give us the left solution? Obviously from negative infinity, of course. This is always going to be the case. From negative infinity to, we have the solutions right here. One is boxed in green and the other, say it again, that's okay. Awesome, with a parenthesis because we don't have the equal symbol. Great job. And, but
Oh, I'm sorry, my bad.
that's okay. And then, that's it. Very
Why
good.
did you get a 2 and a negative 2?
Yeah, that's, I was looking at the wrong.
Say it again.
Oh, okay.
This was an example showing why we switch the symbol of the inequality when we multiply or divide both sides by a negative number. Any questions? Any questions? Any questions?
I did.
Yes, go ahead, Tiffany.
So when you're writing out the, what is that problem called down here again? The last.
The union?
The union.
Yes,
You're writing out the union since we
Yes.
had X was, greater than 16. we're
Yes.
always gonna put 16 first. And then the,
greater than 16 means this. Greater than
okay,
16,
okay.
right? So less than -8 means this, but still we have to write from left to right. So we have to start with negative infinity. Yes?